Hey there. Today we're looking at lesson 8.3. I'm going to do this just like we've been doing the others. So the first part will be examples 1 through 4, and the second part will be looking at examples 5 and 6. Looking at geometric sequences. Remember that arithmetic sequences had terms that were separated by a common difference. For a geometric sequence, those terms are separated by a common ratio. That means that any term divided by the preceding term should equal the same value. We call that value R for common ratio. So for example, if I have a sequence that looks like 3, 6, 12, 24, and I'm checking to see whether it's geometric. If I divide 6 by 3, that should be the same number I get if I divide 12 by 2, 24 divided by 12, and they are all equal to 2. And so 2 is the common ratio, and this is a geometric sequence. Notice that if that common ratio is greater than 1, the terms will be increasing. If the common ratio is between 0 and 1, then the terms will be decreasing. And these form, when you graph those individual points, an exponential curve. And if that common ratio is less than 0, then the signs will alternate. The signs of the terms will alternate, positive to negative. If we want to write a rule for the common term, for a geometric sequence, that rule looks like a sub n equals a sub 1, so the first term, times that common ratio, which has been applied to the n minus 1 times. Go grab my marker. Now, it looked a little faint. I wasn't sure you could see it. Look at example number 2 at the top of, well, look at example number 1 and just make sure that we can see whether those are common ratios and whether they are geometric sequences. So if you look at example 1, and that was 6, 12, 20, 30, 42, what's going to be your test? Right, you're going to divide them. So is 12 divided by 6 equal to 20 divided by 12? No, I don't think so. So that one is not a geometric sequence. But if you look at the B, 256 divided by 64, 16 divided by 64, 4 divided by 16, 1 divided by 4, you're getting a common ratio of 1/4, and therefore that sequence is geometric. Then we talked about writing rules, so remember, a sub n, the nth term is the first term, times that common ratio, which has been multiplied n minus 1 times. This is the nth term. I'm starting with this one, so n minus 1 times that common ratio will bring me to that nth term. Suppose we have a sequence that looks like example 2a, which was 5, 15, 45. And we want to know whether this is geometric. I'm writing the rule, so 135, let me finish that, a little weird. And I want to write the rule. So the first thing is to start, I know it's going to be a sub n. They've told us it's geometric, it's always a good idea to check. So 15 divided by 5 is 3, 45 divided by 15 is 3, 135 divided by 45 is 3. So it's geometric, they were not lying to us. So the first term is 5. And the common ratio we just found when we were doing our test, so the common ratio is 3, and the rule will be a sub n is the first term, which was 5, times the common ratio to the n minus 1. Then they asked us to find the 8th term, so a sub 8 is going to be 5 times 3, 8 minus 1 is 7, and when I plug that into my calculator, I should get 10,935 for my 8th term. Looking at example B, this is still on that same page, still example 2. The B example, they gave 88 and negative 44 and positive 22 and negative 11 and said, write the rule. So is it geometric? Well, negative 44 divided by 88 is 1/2, negative 1/2, and 22, negative 1/2, and negative 1/2, so it's geometric. And we just discovered that our common ratio is negative 1/2. And so we are ready to write the rule. The nth term is going to be that first term, which is 88, times the common ratio, which is negative 1/2 to the n minus 1. And then they asked us to find the 8th term. So a sub 8 is 88 times negative 1/2 to the 8 minus 1, which is 7, which when you calculate is negative 11/16. Look at monitoring progress, which is in the middle of that page, to 427, and you are writing the nth term for 3, 5, 15, 75. You can pause here and do it. Or just stick with me and we'll do it together. So common term a sub n is the first term times r to the n minus 1. We're looking for the nth term. The first term is 3. The common difference is 15 divided by 5 is 3. It should be 15. That should be 75. It should be 375. Now that we match what the book has, and we're dividing, it's geometric. And so 15 divided by 3 is 5. 75 divided by 15 is 5. So my common ratio is 5. My first term is 3. And we are multiplying it to the n minus 1. If I'm looking for the 9th term in this one, so a sub 9 is going to be 3 times 5 to the 9 minus 1, which is 8. And when we plug that in, we get 1,171,875. Is that what you got? If you paused, and if you didn't, there it is. Now don't turn the page. Look at the next one. Writing a rule if you're given a term, not the first term, and a common ratio. So remember the rule. This is what's going to guide us. So in this example, they gave us a term, a sub 4, and they told us that that equaled 12. And we had a common ratio of r equal to 2. And our job is to write a rule for the nth term, and then find the first 6 terms. So if I'm going to use that general rule, the term that I know is 12, and it was the first term, which we don't know, that's what we're trying to find out, multiplied by that common ratio to the n minus 1. Well, this is 4, so 4 minus 1 was 3. So now we know that 12 was 8 times a sub 1. And I'm just going to divide by 8, so 12 eighths is a sub 1, and when we divide that, we'll find out that that's 3 halves. You can leave it as a fraction, or you can turn it to 1.5, whichever way suits. And so now our rule is going to be a sub n is the first term. Now that we know that that is 3 halves or 1.5 times our common difference r, which is 2, to the n minus 1 would be our rule. To find those first 6 terms, you could do a table of values. So x and y, 1, 2, 3, 4, 5, 6, and plug in for n and see what you get. Remember, x is the n. And if you look at the graph, look what they did when we did that at the bottom of that page. Look at the graph. Makes an exponential curve, and remember not to complete the curve, just the dots are all that that function is defined for. Turn the page, look at example number 4. Keep our common rule up there. This time we're asked to write a rule given 2 points. And so in the book they used a sub 2, and they told us that that was, what did they tell us? That was 12. And they gave us the 5th term, so a sub 5. And they said that was negative, excuse me, 768. And so we were asked to write a rule for the nth term. So I'm going to start by taking those 2 terms and looking at that general form and seeing what we have. So we know that 12 was the first term times the common ratio. We don't know the first term, we don't know the common ratio, but we know it was 12 was the first term in that common ratio. 2 minus 1, n is our 2, so r to the first. And using that equation, we now know the first term is 12 divided by r. Well, that helps a little bit. Well, let's come look at this one. If I know that a sub 5 is negative 768, that means negative 768 was that first term times the common ratio. 5 minus 1 is 4. And so into this equation, I'm going to replace the a sub 1 with 12 over r. So negative 768 equals 12 divided by r. That was our a sub 1 term, times r to the 4th. Well, now that doesn't look so bad because I've got something to work with and I just have one variable. So when I simplify over here, negative 768 is 12 r cubed. That looks better and better. I'm going to divide by 12 on both sides. Negative 64 equals r cubed. Now all we have to do is take the cube root of both sides. So when we do that, r is the cube root of negative 64, which is negative 4. Now that we know what r is, we're going to come back to this first term. And now we know the first term because it was 12 divided by r, which is negative 4. So negative 3 is our first term. And now we're ready to write that rule using this. A sub n is the first term, which we now know is negative 3, times the common ratio, which we know is negative 4, to the n minus 1. Look at monitoring progress on page 428. This is where we're going to stop. Look at number 5 and number 6. You can pause and do them on your own. That would be preferable. Or, I don't know how you feel about pausing videos. Probably just sit there and watch with me. So look at number 5. They gave us a sub 6, and they told us that was 96. And they told us the common ratio was negative 2. And our job is to find that first term so that we can write the general rule. So 96, that's my a sub n, is that first term that we're looking for, times the common ratio of negative 2. This was the sixth term, so 6 minus 1 is 5. And I'm raising that negative 2 to the fifth term. That means negative 90, sorry, it was negative 96. That means negative 96 equals negative 32 times a to the first, and when we divide, 3 equals a sub 1. Now we can write the rule for that. So a sub n is the first term that we just found, times the common ratio that they gave us to the n minus 1. If they asked us to create a graph for the first 6 terms, create that table of values, plot those points, and there you go. If I'm looking at number 6, that was 5, monitoring progress 5. Look at number 6, where they gave us 2 values. They told us a sub 2, and we were told that that was positive 12. And we know that a sub 4 was positive 3. So I'm going to write those 2 rules. A sub 2, I don't know what the first term was, but r to the, this was 2, so r to the first. And so a sub 2, they told us was 12. So 12 equals a sub 1 times r to the first, and that means a sub 1 equals 12 over r. Doesn't matter if it's not that nice because it's going to cancel when you get here. This is just an example to look at. For this one, they told us a sub 4 equals 3. And so I'm going to write that same equation. So 3 equals the first term times r to the 4 minus 1, or 3. I know that a sub 1 is 12 over r, so we're going to replace that. So 3 equals 12 over r times r cubed. I'm canceling, so 3 equals 12 times r squared. That means that 1/4, when I divide both sides by 12, equals r squared. And that means my r is plus or minus, remember, 1/2. If my ratio is plus or minus 1/2, That means over here I have a possibility of two sequences. So R is, if I put 12 over positive 1/2, that means 24 is my first term. If I put negative 1/2, then negative 24 is my first term. And I have two sequences. One sequence that looks like a sub n is the positive 24 times R, which we now know was 1/2 if I'm using the positive 1 to the n minus 1. Or a sub n was negative 24 times negative 1/2 to the n minus 1. Two sequences because I had plus or minus two values. That's where this lesson is going to stop. Your homework is posted. I think it's 8.3, it's worksheet 1. It'll be posted on your assignments, and you can find that worksheet in topics. Download it like you've been doing it, and I'll see you the next time to finish this lesson.